Hello students, today we are going to discuss electrostatic problems. An electron at rest has a charge of 1.6 into 10 power minus 19 coulomb. It starts moving with a velocity v equal to c by 2, where c is the speed of light, then the new charge on it. This is the basic property of electric charge, that electric charge do not depend on the speed of the particle. Okay, so charge value will remain same. So answer to the given question is option 1. It is unlike mass. Charge do not depend on velocity. Okay, electric charge is not a function of velocity, unlike mass. While mass depends on the velocity, m effective equal to m rest divided by under root 1 minus v square upon c square. Okay, so the answer to the given question is option 1. The force between an alpha particle and an electron separated by a distance of 1 angstrom. 1 angstrom means 10 power minus 10 meter. Alpha particle means charge is 2e. Force will be attractive. The force value will be equal to 9 into 10 power 9 2e into e upon r square, that is 10 power minus 10 square. After solving this, we will get 18 into 1.6 into 10 power minus 19 square into 10 power 9 divided by 10 power minus 20. After solving this, we will get 18 into 2.56 into 10 power minus 38 into 10 power 9 into 10 power 20. After solving this, we will get approximately, this is 20 into 2, 40. This is how much? 29, and this is 38. So this will become 29, 38 means minus 9. 18 into 2, approximately 40. 40 into 10 power minus 9 means 4 into 10 power minus 8. So don't need to solve. This force is attractive. Okay, alpha and electron. So answer to the question is option 3. So directly we can write, this is 46 into 10 power minus 9 means 4.6 into 10 power minus 8 Newton. The force will come negative. Negative sign shows that force is attractive. Okay, so out of 4 choice, the correct choice is option 3. In exam, during making calculation, you have to make the adjustments. 3 equal charges Q are placed at corners of an equilateral triangle. The force on any charge is, see, this is the question. 3 equal charges are placed at the corner of equilateral triangle like this. Let us assume side of the triangle is A. Now, direction of electrostatic force always remains along the line joining 2 point charges. So force on this Q due to this Q will be in this direction, and this is equal to kq square upon a square. And force on this due to this will be in this direction. This is also kq square upon a square. And angle between these two forces is 60 degrees. So result from vector analysis, the resultant will be equal to kq square upon a square root 3. So out of 4 choice, the correct answer is option 2. 5 point charges, each of value plus q coulomb, are placed on 5 vertices of a regular hexagon of side L meter. The magnitude of the force on a point charge of value minus q coulomb placed at the center of hexagon is. Dear student, this is the situation. Five point charges, each of value q. And now a charge minus q coulomb is kept at the center. Now force at this charge will be, see here, force due to this and this will get cancelled, force due to this and this will get cancelled, force due to this will be in this direction. And in case of regular hexagon, all sides are same, this is also L, so force will be equal to kq square upon L square. Okay, So out of 4 choice, the correct choice is option 1. So answer 1 is the correct choice. 6 charges plus Q each are placed at the corners of a regular hexagon of side A. The electric field at the center of hexagon. This is general property. In case of symmetrical charge distribution system, at the center of symmetry, electric field intensity remains 0. So electric field at center will be 0. So option 1 is correct choice. Because electric field of opposite charges will cancel each other. So option 1 is the correct answer. Charges of 10 by 3 into 10 power minus 9 are placed at each of the four corners of a square of side 8 centimeter. The potential at the intersection of the diagonal is. See, this is the question. The charge value is Q equal to 10 upon 3 into 10 power minus 9 coulomb. Q. The length of the square is 8 centimeter. So this will become 8 root 2 and this is 8 upon root 2 centimeter. So the potential potential is a scalar quantity. Potential due to one charge is kq upon r. We convert centimeter into meter and due to 4 charges, this is the answer. Now the final answer is 9 into 10 power 9, 10 upon 3 into 10 power minus 9 into 4 into root 2 divided by 8 into 10 power minus 2. After solving this, we get this is 9 into 4. 4 and 8 will get cancelled. And 3 and this will get cancelled. 3, this will become 1.5 root 2 into 10 power 9, 10 power minus 9 will get cancelled. This will become 10 power 3. So 1.5 root 2 into 10 power 3. Root 2 means 1.414 means 1500 root 2. So option 2 is the correct answer. 1500 root 2 volt. Out of 4 choice, the correct choice is option 2. ABC is equilateral triangle of side 1 meter. Charges are placed at its corners as shown in figure O. O is the midpoint of side BC. The potential at point O is. See, it is an equilateral triangle, side length is 1 meter. So this is how much? 1 square minus 1 upon 2 square. This is how, this is equal to 1 minus 1 upon 4, 3 by 4. Means under root 3 by 2. So now, potential at this point O will be equal to, this is minus 2 microcoulomb, minus 3 microcoulomb, 9 into 10 power 9. We are directly adding minus 2 and minus 3, minus 5 into 10 power minus 6 divided by R. This is 1 upon 2 plus 9 into 10 power 9 into 6 into 10 power minus 6 upon root 3 upon 2. And this is also minus because charge is minus. So this is the answer. Now let us calculate. In option there is only one answer in negative. Okay, so this should be the answer. So no need to calculate, just write because only one negative answer is there. Okay, so option, let us make option 4 correct answer. Otherwise you can try and make the calculations. Okay. 3 charges are placed as shown in figure. If the electric potential of the system is 0, then Q upon Q is. Dear student, potential of the system can be written as K QQ upon R plus KQ square upon 2R plus KQQ upon R. This is also minus equal to 0. So after solving this, we will get KQ square upon 2R equal to 2KQQ upon R. KK will get cancelled, QQ will get cancelled, RR will get cancelled. So Q will become equal to 4Q. This is the answer. So Q upon Q equal to 1 upon 4. This is the answer. Option 4 is the correct choice. Which of the following diagrams show the correct lines of force? For point positive charge, electric field lines are radially outward. For point positive charge, electric field lines are radially outward and the electric field lines originate from positive charge. Okay. So out of 4 choice, the correct choice is option 2. Option 2 is the correct answer. In figure, shown the electric lines of force emerging from a charged body if the electric fields at A and B are E and EB respectively, if the distance between A and B is R, then dear student, in the direction of electric field, electric potential decreases and crowded electric field line indicates higher value of electric field. If separation between electric field is less, then value of electric intensity will be more. So at A point, electric intensity will be high. So EA greater than EB because here separation is less. So out of 4 choice, the correct answer is option 1. The dependence of electric potential V on the distance R from the center of a charged spherical shell is shown by. Dear student, in case of charged spherical shell, inside the shell potential remains constant and outside the shell V proportional 1 upon R. So out of 4 choice, the correct answer is option 2. At R less than R, V remains equal to KQ upon R, and at R greater than R, V remains equal to KQ upon small r. So graph is option 2. The electric potential at a point due to an electric dipole will be, this is direct formula, electric potential is Kp cos theta upon R square, this is Kp dot R vector upon RQ. So out of 4 choice, the correct answer is option 1. An uncharged sphere of metal is placed in a uniform electric field produced by two oppositely charged plates. The lines of force will appear as. This is very good question. Inside conductor, electric field intensity is 0. Electric field line emerge and converge only perpendicular to the conducting sphere surface. Okay. So out of 4 diagram, the correct answer is option 2. This is option 1. This is option 2, and this is option 3, and this is option 4. So option 3 is the correct answer, because at the surface of conductor, electric field line comes perpendicular to the surface, because a conductor surface is equipotential surface. ABC is an equilateral triangle. Charges plus Q are placed at each corner. The electric intensity at the center of triangle. In case of symmetrical charge distribution system, electric intensity at center of symmetry always remains 0. This electric field will nullify this electric field. Okay, so answer is 0. So out of 4 choice, the correct answer is option 4. The electric field intensity due to a thin, infinite, long, straight wire of uniform linear charge density lambda at O. Electric field due to this wire and this wire will get cancelled, and electric field due to this semicircular is equal to 2k lambda upon r sine phi by 2. This is lambda upon 2 pi epsilon 0 r. So, and direction will be this. So out of 4 choice, the correct answer is Option 1. For two infinitely long charge parallel sheets, the electric field at P will be, dear student, due to this sheet, electric field intensity will be sigma upon 2 epsilon 0, and due to this sheet, electric field intensity will also be sigma upon 2 epsilon 0. Both electric field are acting in opposite direction, so electric field intensity finally will be 0 between the plates. Okay. So out of 4 choice, the correct answer is option 4. Figure shows the variation of electric intensity versus distance x. What is the potential difference between the points at x equal to 2 meter and at x equal to 6 meter from O? Dear student, the area under electric intensity distance graph will show E equal to what? Minus dV upon dx. So dV is what? Minus E dx. So dear student, area will show change in potential. Okay. So here this area is how much? Half into 2 into 10. So means this is 10. And this area up to 6 is how much? Area of trapezium 2 plus 6 upon 2 into 10. This is how much? 40. So 40 minus 10, this is equal to 30 volt. Okay. So out of 4 choice, the correct answer is option 1. Dear students, electric field line and equipotential lines remains perpendicular to each other. Figure shows a set of equipotential surfaces. The magnitude and direction of electric field that exists in the region is. These are the set of equipotential line. In the direction of electric field, potential decreases. So this is the direction of the electric field. Okay, now this angle is 135 degree. So this angle is how much? This is 45 degree. And this is 90 degrees. So this is also 45 degree. We can find this perpendicular distance. How? Cos 45 equal to base upon hypotenuse. This is 1. So D equal to what? 1 upon root 2. This is in meter. So electric intensity will be equal to how much? If we take 20 volt, 30 volt. So electric field equal to 30 minus 20 upon D. So this is equal to 10 root 2 volt upon meter. 10 root 2 volt upon meter at 45 degree with x-axis. Okay. This is direction of electric field at 45. This is also important, at 45 degree with x-axis. So option 1 is the correct answer out of 4 choice. This is very important thing you have to see, you should know. In the direction of electric field, electric potential decreases. Okay, here electric potential decreases. So this is the direction of electric field, and according to trigonometry, this angle is positive. Okay, positive axis. Okay, 10 root 2 volt upon meter at 45 degree with x-axis. This is the value of electric field.